Hey everyone, today we're going to explore the data visualization in Python. So we will learn how to create different types of plots and how to visualize data effectively by using Matplotlib. So let's get started. So by the end of this lesson, you will be able to understand the different types of plots in Python can produce. And then next you will learn how to create a scatter plot, and finally you will learn how to create a line plot. Matplotlib is a very powerful library that allows us to create static, animated, and interactive visualization in Python. So to use Matplotlib, we need to import it at the beginning of our Python script by using this import statement. So here I am using PLT as the simplification of the library name. And again, it is common among the Python programmers to use PLT as the abbreviation, but you are free to choose your own name. So there are several types of plots that we can create, which includes the two-dimensional plots. So we have the scatter, the line, the error bars, the contour, and the bar plot. And then we have the three-dimensional plots, which is the surface plots. And in this lesson, we'll just focus on the scatter, line, and the error bars, and also the surface plots, as these are commonly used in physics, and the rest are yours to explore on your own. But you don't have to worry about this. So they will follow the same basic principle that we will cover today, and you will have no trouble in understanding them. A plot consists of different elements, such as the axis, and then we have the plot title, the inset plot, the axis label, and also the plot itself. First things first, we have to set up the axis. We have to set up the 2D axis, so it is the same for both plotting data points and also plotting a line function. When we focus on plotting the data points, we will need to prepare the data table, which comes from our experiment. And then next, we add the points to the axis, and then finally, we show the plot. So now you imagine that you're doing a lab experiment where you measure and record the data points, and then you want to visualize these points using, you want to visualize these points along with a theoretical curve and see how well they match. So the process of data points visualization in Python by using Matplotlib follows the given approach. So here we follow this particular path to create the scatter plots of our experimental data points. So first, we set up the axis. Then next, we prepare the data table, followed by adding the data points to the axis, and finally, we display the scatter plot. So before we start plotting, we need to set up the necessary libraries. So we import matplotlib.pyplot as PLT for visualization, NumPy for numerical operations, and pandas for the case where we need to handle data tables. And then next, we activate the axis by using the GCA functions, which gets the current axis and allows us to configure the plot. So with this particular setup, we are ready to move forward with data visualization. Now let us configure the axis. First, we set the labels for both axes. Here we have x in centimeter and y in centimeter. And then next, we define the axis limits. So for example, the x limit begins from 0 to 10, and then the y limit begins from 0 to 100. It is just an example. So later you will have to improvise this information so that your plot will be displayed nicely. So with these settings, our plot now is well defined and ready for visualization. So now let's prepare the data table. So we create a two-dimensional Python list by using NumPy to store the data points. So basically we generate the data points. This is one of the examples. Each row represents a measurement. This is the row, and this is another row. So in this example, I'm just using two rows, but in the real experiment, there could be more. So the first value here is the x coordinate, the second value is the y coordinate, and the z, and then the third value is the measurement error. So whenever you do the measurement, it will always comes with the error. So the error will go to the third value here. So for example, our first data point is at 1 and 1 with an error of 1. So the second point is 2, 4 with the error of 1. We can also construct our plot by using pandas. So we convert our NumPy array into a pandas data frame, and then we assign the column names x and y as the coordinates, and we have the ERRY, which is error of y, for the measurement errors. So here we create the table with columns x, y, and error of y. Well, instead of manually defining data points in a script, we can also take a shortcut by storing our data in a CSV file So here you imagine that you do your experiment. When for each measurement you save the information in the CSV file. And then afterwards, we use pandas, where we simply read the CSV file into a data frame. So this will allow us to quickly load and process large data sets with ease before visualization or analysis. So again, the CSV must contain 3 columns, as the previous example, which is X for the X coordinate and Y for the Y coordinate, and the error of Y for the measurement errors. Now that we have our data stored in a pandas table, so it is time to visualize it. So here we save the information from the CSV file into the table data frame. And by using the scatterplot function, like so, we can plot the data points directly from the table onto the axis, making it easier to analyze trends and relationships in data sets. Well, customizing the appearance of a scatter plot allows us to enhance the visualization clarity, of course. So by adjusting parameters like the marker style, the color, and also the size, well, we can tailor the plot to highlight key data points and improve readability. But wait, where are the error bars? So yeah, we can also add error bars to our scatter plot to indicate measurement uncertainty. Previously, we had 3 columns, X and Y, in our CSV file, but now we will need to use the error of the Y measurement. So again, we must add the 3rd column, which is the error of Y, to define the sizes of the error bar. So here we are using the 3rd column of our CSV file, which is the error of Y. So there are a couple of options that we can modify. For example, the format, which is the FMT, which determines the marker style, whether it is a plus symbol or the minus or the dot or the cross. So we also have the cap size, which determines the size of the error bar cap. So this is the cap of the error bar, and then we have another cap of the error bar. And also we can control the color of the error bar, whether it is red, blue, or green. So it is up to your preference. Once everything is ready, we can invoke the plt.show function to display the plot window. Now, plotting the experimental data with a scatter plot is useful, but it is not enough. It is also important to include the theoretical curve to compare predictions with actual results. So typically, this model is a mathematical function that represents the expected trend of the data. We outline the steps for plotting a function in Python by using matplotlib. So we will need to use this path. And finally, we show the plot. So first, we set up the axis as usual as the framework for the visualization. And the next, we define the function f of x, which is the mathematical function that we want to plot. And then next, we generate the grid of x values to evaluate f of x smoothly. It means that we create the grid of x, and then next we compute the corresponding values of f of x for the given grid. And then finally, we add the plot to the axis, completing the visualization. And by following all steps here that we've outlined, we can effectively plot the line function in matplotlib. So now let's look at how this works in the code. Well, we first need to define our theoretical curve. So assume that we want to plot the function of x to the power of 2. Well, we will leave the x parameter here without specifying a type, because later you will see that x will be a NumPy array. So in NumPy, mathematical operations like this are applied element-wise. So this means that every value in the array or in the x array will be squared individually without needing a loop. So next, we need to generate a grid of x. So here is an example of a grid of x. So we use the NumPy's linspace functions, which creates a linear grid from 0 to 10 with 100 evenly spaced points. So this will ensure a smooth curve when plotting. So the more points you add, the smoother your curve. So that is the key idea. But it will take time to produce a plot because you have because your grid is large. So there are other grid options available, such as the log space, which generate points on a logarithmic scale. So in the case where you want to use the log scale, then you have to use the log space function. So however, for now, we will just need to stick with the linspace for uniform distribution of points. So I suppose now that we have our theoretical function ready and the grid of the x values also ready, it is time to plot the curve. So we use the plot function here to plot the function values against the grid. So the color equals to green here, sets the curve color to green, and we have the line width, which is 2, which makes the line thicker for better visibility. We also specify the line style, which is the dotted line. It creates a dashed line style. So other styles are available, such as for a dotted line, for a dash dot, and there are many other patterns. Here are some examples that you can explore. So this step will ensure that the theoretical curve is clearly represented on the plot. Once everything is ready, we display the plot window by using the show function over here. Congratulations, we have reached to the end of our lesson for now. So before we leave, I need you to remember a few key points. So the first point is to use scatter for 2D scatter plots, and we use the plot function for the surface plots. So these functions are important. And then next, add error bars by using the error bar function. And then we use the NumPy linspace functions to generate the grid. So the grid is basically a NumPy array which will be fed into your x for your function f of x. So the x here is basically the NumPy array generated by the linspace. So and that's it. So now you know how to visualize your data using Matplotlib in Python, and I suggest you to try experimenting with different data sets and visualization styles. So great. I'll see you in the next video. Bye bye.